Welcome to the Connecting to Remote Ethernet Equipment via Cellular video. A typical M2M data communications system is set up for the remote equipment to initiate a cellular connection to a centrally located server, either on a schedule or upon a trigger event. That type of mobile-originated cellular M2M system is relatively easy to set up. A mobile-terminated M2M system is set up for an operator at a terminal to initiate a cellular connection to the remote equipment. Setting up that type of cellular M2M system requires special consideration. This video will present a practical solution for a mobile-terminated M2M system that can work with automated systems that have an application running on a server or with a manually operated terminal. In part 1 of this video, I'll present a solution for a mobile-terminated M2M system by describing the target equipment, the USR 3510 cellular gateway, the Ethernet interface between the target equipment and the cellular gateway, the terminal, the cellular network, and the gateway's inbound port forwarding feature. In part 2 of this video, I'll demonstrate how to set up a mobile-terminated M2M system using typical equipment and suitable cellular services. I'll demonstrate how to configure IP addresses that allow an Ethernet connection between the gateway and the target equipment, and how to configure the cellular gateway for connectivity between the target equipment and the cellular network, and how to verify cellular connectivity to the gateway. And finally, I'll test the end-to-end connectivity to the target equipment. Now, part 1, the solution. The M2M system presented in this video communicates with remote equipment that has an Ethernet port, typically by accessing its embedded graphical user interface. The target equipment's Ethernet interface has an IP address, which must be static, a subnet mask, and a port number. Also, the target equipment's Ethernet protocols may or may not include DHCP. The system will use a USR 3510 as a gateway between the target equipment and the cellular network. The gateway has an Ethernet port and is configured via a graphical user interface. The gateway's Ethernet interface has an IP address, which is static when the Ethernet port is in LAN mode, a subnet mask, and a port number. And its Ethernet protocols do include a DHCP server. The cellular service provider must provision the gateway's cellular interface with a static IP address, and the gateway will be configured to listen for connections at a user-defined port number. The cellular gateway will interface to the target equipment over an Ethernet connection. Both the gateway and the target equipment have a subnet mask, which are probably set to this value by default. With this subnet mask value, the first 3 numbers in an IP address are the network prefix, and the last number is the host identifier. The default IP address of the gateway's Ethernet port is 192.168.1.1. Let's say that the IP address of the target equipment's Ethernet port is 192.168.1.90. The Ethernet connectivity works because the gateway's network prefix and the target equipment's network prefix match, and because the gateway's host identifier and the target equipment's host identifier are not the same. Also, when any DHCP server is enabled, it's good practice for the target equipment's host identifier and the gateway's host identifier to be set outside the DHCP range to avoid any possible address conflicts. If necessary, change the DHCP range, or change the IP addresses, or disable the DHCP server. The operator will use a terminal, which is usually a computer with a web browser and a connection to the Internet. It must have an Ethernet port, which will be used for configuring the target equipment and a cellular gateway. And the computer's Ethernet protocols usually include a DHCP client. To make a mobile terminated connection over the cellular network to a remote cellular gateway, the terminal first connects to a local area network, which gives it access to the Internet. The local area network will undoubtedly have a firewall to protect it from threats on the Internet. The cellular gateway will be connected to a private cellular network, which gives it access to the Internet. The private cellular network will also have a firewall to protect it from threats on the Internet. But the firewall also blocks connections from the terminal. So a VPN tunnel must be set up so the terminal can connect through the firewall and into the private cellular network. And the cellular gateway must be provisioned with a static IP address that never changes. The private cellular network, the VPN tunnel, and the static IP address are typically not available from a consumer-grade cellular data plan. Contact USR for help finding a suitable M2M cellular service provider. Once the cellular services are set up, connectivity to the cellular gateway can be tested with a ping command. Note that ping cannot test connectivity all the way to the target equipment. For the cellular gateway to respond to ping, it must have ICMP enabled. Note that ICMP is disabled by default. The operator enters a ping command at a command prompt using the IP address that was provisioned for the gateway. The ping should return to the terminal if the cellular network, the VPN, and the gateway are properly set up. To pass connections through the cellular gateway to the target equipment, use the gateway's inbound port forwarding feature. Here's how it works. The operator enters the IP address of the cellular gateway into a web browser, along with a port number. The IP address opens a connection to the cellular gateway. A port forwarding rule that's been set up in the gateway translates the port number into the IP address and port number of the target equipment, which forwards the connection to the target equipment. Then data can transfer in both directions across the connection. There are two approaches to building a system that has two or more target units. One way is for each target unit to have its own cellular gateway. Each gateway is identified with a unique IP address. All target units can be identified by one common destination port number. Here's a tip. If you use port 80, you won't have to type it into the browser because the browser default is port 80. All target units may be assigned one common IP address, and every target unit can use the same port number. Using this approach, all target units have identical configurations, and all cellular gateways also have identical configurations. With the other approach, the target units share a single cellular gateway by using a switch or router. The gateway is identified with a single IP address, and each target unit is identified by a unique port number. Each target unit connected to the gateway must be assigned a unique IP address, and every target unit can use the same port number. Using this approach, the cellular gateway is configured with a port forwarding rule for each target unit, each rule translating a destination port number into a target IP address and port. The benefits of this approach is the lower monthly cost of just one cellular data plan. That's how a mobile terminated cellular M2M system works. Now, part 2, a demonstration. Note that the configurations shown in the following demonstration are based on my target equipment, my cellular services, and my networking preferences. Each M2M application is unique, so these configurations will not apply in every application. Contact USR for guidance in configuring your M2M application. For a prototype system, the terminal, the gateway, and the target equipment should all be accessible at the test location. In this example, the terminal is a Windows 7 laptop computer. This computer has one Ethernet port that will be used for a connection to the Internet and for configuring the gateway and the target equipment. Windows has DHCP enabled by default, and the web browser on this laptop is Chrome. The USR 3510 cellular gateway will start with these factory default settings. I'll write down these settings for later use. The gateway has been set up with connectivity to a cellular network. For details of how to set up connectivity, watch these videos on the USR website or at the US Robotics channel on YouTube. In this demonstration, my target equipment is a Hitachi SimpleNet NAS box. At factory default, this NAS box is a DHCP client. To access its user interface, I must connect my terminal to a router and connect the router to the NAS box so the router can assign an IP address to the NAS box. When configuring your target equipment, you'll have to know how to access its user interface and how to configure its IP address and port number. The cellular service for this gateway is a 5 megabyte data plan, and it has a static IP address. And my cellular service provider has set up an L2TP VPN tunnel between my terminal and their network. And I'll be using two short Ethernet cables to make connections while configuring the equipment and testing the setup. The demonstration begins by choosing the IP addresses of the gateway and the target equipment so they can connect over Ethernet. In this example, I prefer to keep the gateway's default IP address and choose a new IP address for the target equipment. The default IP address of the gateway is 192.168.1.1. The target equipment will require a static IP address with a network prefix that matches the gateway's network prefix, and a host identifier that's not the same as the gateway's host identifier, and doesn't conflict with the DHCP range of the gateway. In this example, I'll choose the target equipment's address to be 192.168.1.251. I'll write down this new target IP address for later use. Now I'll configure the target equipment with that new IP address. My terminal is a DHCP client, and the NAS box is also a DHCP client, so I have to connect the terminal and the target equipment both to a router. Now I'll launch my web browser. I know the IP address that the router assigned to the target equipment, so I'll enter it into my web browser. The target equipment prompts for a login, so I'll enter the default credentials. This is the embedded user interface of the Hitachi NAS box. Now I'll change the IP address to the new IP address that I picked. And I'll save the changes. In this example, the target equipment's port number is fixed to port 80. The target equipment configuration is now complete. And I'll disconnect the Ethernet cables from the target equipment and router. Next, I'll configure the cellular gateway for inbound port forwarding and ICMP. Before proceeding, be sure that the cellular gateway has been configured to prevent unintended excessive data usage. Details about excessive data usage can be found at this USR web page. The cellular gateway's DHCP server is enabled, and since Windows uses DHCP by default, I can just connect a short Ethernet cable from my terminal to the gateway and switch to my web browser. I'll enter the cellular gateway's IP address into my web browser. The gateway prompts for a login, so I'll enter the default credentials. This is the embedded user interface of the cellular gateway. First, I'll configure inbound port forwarding. I select the Firewall tab and scroll down to inbound port forwarding. Initially, no rules are configured, so I'll add a new rule. For this example, I'll choose port number 2311 to identify the target equipment, and I'll enter it into the destination port text box. Next, I'll enter the new IP address of the target equipment into the target IP address text box. Then I'll enter the port number of the target equipment into the target destination port text box. I'll leave protocols set to TCP, leave inbound interfaces set to all, and leave source IP set to any. Then I'll save this rule by clicking the Add button. Now I'll save the inbound port forwarding changes by clicking the Save Changes button. Next, I'll enable ICMP so the gateway will respond to a ping test. I'll select the Interfaces drop-down list, choose 3G connection, and scroll to the General settings. To enable ICMP, I'll change the Allow ICMP setting to Yes and click the Save Changes button. The gateway configuration is now complete, so I'll close the browser and disconnect the Ethernet cable from the terminal. Now I'll verify cellular connectivity to the gateway. I'll connect the terminal to the local area network, which gives me access to the internet. The gateway has previously been set up with connectivity to a cellular network, and a VPN tunnel has been set up. So now I'll use a ping command to test connectivity to the gateway. At the command prompt, I'll enter the ping command with the IP address of the cellular gateway. This response confirms that I have cellular connectivity to the gateway. If this test had failed, I would check that the cellular gateway has a cellular connection, check that I used the static IP address that was provisioned for this gateway, and check that the VPN was correctly installed and enabled. Finally, I can test connectivity to the target equipment. I'll use a short Ethernet cable to connect the gateway to the target equipment. Now I'll launch my web browser again. I'll enter the cellular gateway's IP address and the destination port number into my web browser. The target equipment prompts for a login, so I'll enter the default credentials. This is the embedded user interface of the NAS box, sent to me over the cellular connection. This confirms that I now have end-to-end connectivity to the target equipment. Note that displaying the login prompt and this home page on my terminal consumed approximately 200 kilobytes of billable cellular data. You must choose the size of your cellular data plan based on the size of your equipment's user interface and how often you'll access it. In this video, I've explained how to set up and test a cellular M2M system to make mobile terminated connections to remote target equipment. The setup requires a VPN tunnel connecting the terminal to a private cellular network and a cellular gateway that's provisioned with a static IP address. The gateways and the target equipment's IP addresses must be selected according to basic networking principles, and the cellular gateway must be configured for inbound port forwarding and ICMP. For more details about the cellular gateway, see the USR 3510 user guide, which can be downloaded from this USR support page. I hope this video was helpful for understanding how to set up a cellular M2M system to make mobile terminated connections to remote equipment. Thank you for watching, and thank you for choosing USR.